Man, what's going on, ASVAB party people? I'm Coach Anderson, happy to be your ASVAB coach, and we got a treat for you in this video because we got a 2-hour session on polynomial operations. So if you've ever had trouble with a distributive property, or if the only way that you know how to multiply polynomials is FOIL, then this video is going to help you out in terms of learning the basics and learning the general method that works for any size polynomial. Whether it's 2 by 2 for FOIL, or you have 3 by 2 or 4 by 2 or 7 by 7. I got you, I got you, I got you. So stay tuned here. We're gonna have a great time in this lesson. So make sure to take notes. Make sure that you comment where you are learning the best. If there's a part of the video where you see this and you're like, wow, this is awesome. Hey, comment your support. We always love hearing how we're helping you guys succeed. It motivates us to make more videos. And so with that said, before you begin, 10 more seconds here. If you haven't heard of my ASVAB All-Access Program, well then you're missing out. So I have a program that helps all of my students raise their scores and get the jobs they want. As long as you're willing to put in the work, you're gonna get there. Because I'm here to support you all the way, and you can text me when you have questions. On top of that, you get all of these classes, all of the recordings, so you never have to worry about scheduling issues. And on top of that, you get thousands upon thousands of practice problems with video solutions to most of them to really help you break things down, build your confidence, and go into test day prepared to get that job you want. At the end of the day, it's not going to be a game of hoping and wishing for the best. This is skill. This is intentional skill that we have to work on over time. And so, if you're willing to put in that work and you're motivated, go ahead, check the link in the description for the full program details. Click that link, watch the video on how it works, and get your butt signed up so we can raise that score and get you the job that you want. So again, my name is Coach Anderson. Without further ado, let's enjoy our class over here for polynomials. Let's have fun. And remember, comment, like, subscribe to this channel, and let's keep it going. Let's have fun. So here we go, my party people. First things first, we're going to talk about les distributive property. All right, so distributive property. Here's the thing. The way I teach math, and because I have a master's degree in education, blah, 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 but my specialist degree was with mathematics. I've done a lot of math in my life, a lot of teaching. And one way that you're going to find out that I teach is in layman's terms. Can anybody here tell me what it means when I say explaining something in layman's terms? What does that mean? What does in layman's terms mean? Give me in the chat box, grab the mic if you'd like to. Easy explanation. What does it mean when I say, so mainly where we can understand? Yeah, kind of like when I say in plain old English, right? Layman's terms means in simplistic, relatable terms. And so this is how I teach math, in a way where you can understand what I'm saying, and then we'll connect the dots to what we actually see. So we're not doing examples yet. Just take this down in plain old English. Distributive property. Make sure everything on the outside multiplies with everything from the inside. Take a second here. Write that down. Write that down. Make sure that everything on one side, or everything on the outside multiplies with everything from the inside. I'm going to keep this up for maybe 20 more seconds, but just go ahead and write that down. This is the key for today when it comes to that distributive property. Make sure to take all of that down. And if you're getting here, a little late and you're just getting in, just make sure to take a screenshot. Remember that, taking notes is an important part of the process, but you shouldn't be so worried about taking notes that you're not listening and all you're doing is taking notes. We have to find that balance, and I'll make sure to let you know when to put your pencils down and just listen versus straight up taking those notes. Right now, take these notes. So 5, 4, 3, 2, and 1. One more time, distributive property. Make sure everything on the outside multiplies with everything on the inside. Now, there's one more little bit that we have to actually address as well. Hey, remember, before you move on, the ASVAB is not just about memorizing questions. It's about truly understanding what you're doing. So that's why I offer a free practice test that has video solutions so you can learn from every mistake. And on top of that, I offer a free class once a week via Zoom. So go ahead, check out the link here in the description. That way you can sign up, raise your score for free, and get those materials you really need to start building the confidence that you deserve. Let's go ahead, let's ace the ASVAB and get you that job that you want. Let's get to it. Sign up now. Let's go. And that's going to be combining these like terms, okay? Combining like terms and understanding how to add, subtract versus multiply. Be honest, currently, right now, give me a yes or a no. As in, do you currently have an issue remembering how to add, subtract polynomials versus multiply them? Yes, you do have a slight issue with them. You slightly get confused sometimes, or no, you are completely confident no matter what. And again, give me an honest look. I am your teacher. I am not your test grader. So I just want to know, quite honestly, for my own reference in terms of how I'm going to adjust my teaching and the things that I need to look out for to help you out. Okay, so I see a few people saying, yeah, I do get confused. I do see looks like about 1 in 8 people, 1 in 7 people saying, no, I'm all right, I'm good. Salvatore, if it's an it's a yes. So with that, let's go ahead and take these 2 sets of notes down here. So adding and subtracting, when you're looking at adding and subtracting, you need to know what like terms are. So right over here, we have got to get around this idea here, like terms. I'm going to go ahead and zoom in. So we should be taking these notes on adding and subtracting first. Okay. Should be taking notes on adding and subtracting first. And I'm going to bring this right over here next to me. That way you can see it a lot better, especially if you're using your phone. And one more time, if you're using your phone, don't hold your phone like this. Put it like that, please and thank you. That way you can give yourself an easier time. So with that, like terms. Like terms are terms that have 2 things that are the same variable and the same exponent. That's what's going to make them like terms. An easier way to say this in English would just be the same exact variables set up the same exact way. That's another way to say it. So here's what I mean in terms of examples of like terms. Again, same variable, same exponent. Same variable, same exponent. Here are some examples. Some examples would be 3x and 5x. Same variables, same way. Here's another example. 10x squared and 25x squared. Those are examples of like terms. Another good example would end up being, hey, if we have, let's say, xy and 3xy. Those are like terms as well. Another example, and I'm going to go ahead and explain why these examples are good versus the ones that are bad that I'm going to show over there. Okay. So another example of good would be something like this. 12x squared times y and something like, let's say 99x squared times y. That's another good example. Obviously my big old head's delay, but there it is. Now, here's examples of these ain't gonna work, doc. Let me go ahead and push this back over here. And let's go ahead and look at some bad examples. Here's some bad examples. 7x and 2y. Those are not like terms. Everybody, why are those not like terms? 7x and 2y. Why are those not like terms? What's going on, Valerie? Why are they not like terms?
Because it's 7x and then that one says 2y. They're not the same variable.
Exactly. Not the same variable. If they're not the same variable, they can't be like terms. Appreciate you, Valerie, as always. So let's go and give another bad example here. Another bad example would end up being this. We could say, hey, 11x squared and 10x. So we have 11x squared and 10x. Would somebody like to raise their hand and tell me why those are not like terms as well? What's up, Jose? How we doing, my brother? Go ahead, man. Whoops. Hold on. There you go. Go ahead, Jose.
Good, coach. How you doing?
I'm doing all right, man. Doing well.
Because they don't have the same exponent, and you're only supposed to add them when you're multiplying. So If you were multiplying them, then it would be 21x3.
Close. 110x to the third
power.
Well,
yeah, I'm wrong. I was over here adding. Yeah, I'm wrong.
You're good. You're good. Yeah. And we'll talk more about that in terms of the rules for multiplying and dividing right over here. We're going to talk about those rules in a moment. But when it comes to adding and subtracting, in terms of combining those like terms, yeah, those wouldn't be good either because you have x squared and then just a regular x. You need to have the same exponent as well. Here's another bad example, everybody. Another bad example would be, hey, let's go ahead and try to combine 5x squared y and let's say 13xy squared. that would also be a bad example. So we have the same variables. I see an exponent of 2. Why are those not like terms? Would someone care to go ahead and raise their hand and tell me why this one is not a pair of like terms? We have 2's for the exponent. We have x and y. What's going on there? What's going on, Muhammad? Where you at, man? Where's your face?
Oh, I'm sorry, I'm eating lunch. How's it
Oh,
going?
you're good, man.
Because supposed to have x square and x square, or y by itself, or y by itself. No, yeah. So we cannot add different things.
Exactly. We
Multiply,
have to have the
yes.
same variables represented the same way, right?
Yep.
Exactly, man. We have to have the same variables represented the same way. So that would be a bad example as well. And so then, with that said, those are pretty much, some of the basic examples that you really have to worry about on the ASVAB. They're not going to try to trick you too much. These rules are pretty straightforward. Again, they have to have the same variables represented the same way with the same exponents in the same places. The numbers in the front don't exactly matter. These don't matter. It's the variables themselves that matter. So the coefficients being the numbers in the front. The numbers in the front don't exactly matter that much. It's all about those variables and the placements of the exponents. So everybody, before we continue, yes or no, does that make any sort of at least surface level sense? Is it making any sense at all on the surface before we get to some more practice? Because remember, everybody, the way that I'm teaching is first we're talking about the idea, then we start talking about practice, okay? So the ideas are really important to get down because you want to be able to make that connection saying, oh yeah, that's good. Yep, because we talked about this. Oh, this is not good because it doesn't follow this rule. We want to be able to do that because that's the first part of being able to do math well. The decision making, the analysis, and saying, hey, this is good, this is not, this is how we do it, this is how we don't. Now let's actually do it. So with that, let's go ahead and move forward here. Remember, when you're adding like terms and combining these like terms, so adding or subtracting, there's a very, very simple rule. If they are like terms, those variables and the way that they have their exponents and all that good stuff stays the same. All you're going to do is you're going to add those coefficients, those numbers in the front. So I'll give you a couple of examples of what that looks like as well. So everybody, let's go ahead. First and foremost, if I have 7x plus 3x, are 7x and 3x like terms? Yes or no? Yes or no? Oh, and I think I missed a question. Almost missed that. Armani asks, so when adding and subtracting, the variables are the only thing that matter? Yeah, that's the only thing that matters in terms of pointing out if you can actually add or subtract them. And then when you realize that you can, then you worry about those numbers in front. Yep, great question, Armani. Great question, Armani. All right, so let's go ahead and try this. Yeah, you're good. So let's go ahead and understand how we're going to do this, everybody. Especially for those of us that said that we need to see this from scratch. I got you. So look, these are like terms. These are like terms. Because again, they have the same variables and they both have the same exponent. But my question is this, everybody. If a variable doesn't have an exponent, what exponent's on there? If you don't see an exponent, what exponent is on there? Yeah, it's going to be 1. I'm going to ask that question a few more times throughout class. But again, remember this. If you don't see an exponent, the exponent is 1. So write that over here. If you don't see an exponent, the exponent is 1. The exponent is 1. So here's the idea. You could say that 10x is the same thing as 10x to the power of 1. That's all we're saying. It's just an imaginary 1 there. It's like saying, yo, if you just write x, is that the same thing as 1x? Yeah, it's just redundant to say. It's just kind of redundant to say. So with that, Michael, yeah, if you're in my program, I do release all the recordings to all the students in my program. So feel free to check out the program if you'd like to learn more about that. But here we go, everybody. We got 7x plus 3x right up here. Okay, great. What does the rule say? The rule says right over here, add, subtract those coefficients. So here we're adding the coefficients, this thing right here, these coefficients, this right there, 7x and 3. Everybody help me out. Hardest question of the day. What's 7 plus 3, man? This is the hardest question you'll have all day in this class. Yeah, 7 plus 3 is going to be 10. You're basically saying, yo, I got 7 of these x's. I got 3 of those x's. If I add them together, I got 10 x's. So that's going to be 10x. Right there. 10x. Just like that. Not 10x squared. We're just adding. This is the rule for adding and subtracting. We're about to look at the rule for multiplying right now. But remember, when you're adding and subtracting, you're basically adding the amount of those variables. It's like saying, here's another example. If we're going ahead and doing this, if we're saying 13x squared y plus, or I'll just say minus 2x squared y. Everybody, Michael, I was going to say that, but I was trying to keep it chill right now. I'll take my jokes a little to the next level later on. And you guys know me. So here we go. If we're looking at 13x squared y and 2x squared y, everybody, yes or no, before we continue, are these like terms? Are these like terms? Right, these are like terms. We have the same variables set up the same way. Same exponents on the same variables. So x squared y, yeah. So here's how we're going to do this. I want to do this for you in English here. So think of it like this, everybody. If these are the same variables with the same exponents on the same places, all you got to do is say this. I got 13, I'm going to say not x squared y, just say dragons or say light bulbs. Doesn't really matter. I got 13 light bulbs minus 2 light bulbs. How many light bulbs I got left, everybody? 11. And I'm allowed to say that. I'm allowed to code switch because these are the same exact variables. They're like terms. But if I was looking at like, yo, I got 3x plus 7y, I'm not looking at that. I'm not going to be saying, yo, I got 3 antelopes and 7 melons. I can't add that. That's just going to be 3 antelopes and 7 melons. But if I got the same variables the same way, I can say, yo, I got 13 light bulbs minus 2 light bulbs. That's 11 light bulbs. And so here, this would end up being 11x squared y, or code word for us, 11 light bulbs. So is anybody here understanding a little better the concept that you have to have, again, the same variables lined up the same way to be able to add them? Sorry, my big old head's in the way. I know. I know. But this is just a start, guys. This is just the start, because now let's go ahead and review multiplication, and then we're going to be practicing literally all the way up until 8 o'clock. All the way. Okay, just making sure that no one needs that link. All right, cool. So multiplying terms, let's go. When it comes to multiplying terms, very, very sincere rule. We want to follow this to a T right here. Multiply the numbers. So those numbers in the front, multiply them. That's step 1. Let me give myself yellow here. Step 1, multiply the numbers. Step 2, add the exponents of the same variable. Add the exponents of the same variable. So Millie, this is where you would add the variables, or add the exponents, or subtract them. So here we go. I can see clearly now, the rain is gone. These comments. All right, so with that, let's go ahead and try this out here, everybody. First of all, I want to prep you guys with this notion here, this idea of multiplication that, I'm going to be very honest, probably all, but I would say maybe 1 or 2 of the exception who are, maybe struggling a little too much with math, and that's okay. But I'm going to promise you that you probably know this. Everybody, 25 is the same thing as 5 times 5. What's another way to write that? 5 to what? 5, what? How can we write that? Yeah, we can write that as 5 squared, right? We could write that as 5 squared. We could write that as 5 squared. I got another idea for you. So let's go ahead and say we had, I don't know, let's go ahead and say, let's say we got 3 squared, and then we got, we're multiplying 3. Help me out real quick. 3 squared times 3. Let me go ahead and let's work that out here. Everybody, what's 3 squared? That's 3 times 3, right? And then that's times 3 again. Okay, help me out. That would end up being 27 if you did all the math, because 3 times 3 is 9. 9 times 3 is 27. So that could be 27. We could absolutely write that, but that's not what I'm doing here. That's not what I'm trying to prove. I'm going to write it down anyway, but this is not what I'm trying to prove. What I'm trying to prove is the idea that we're going to be working with the law of exponents. Okay. What we're doing here, and this is a class we're going to do, I believe, next 2 weeks from now, law of exponents. This is what I want you to see. If you got 3 times 3 times 3, everybody, how many times is 3 being multiplied by itself? 3 times, right? You see 3 of those 3s. So that means that you can turn this into all this right here. You can turn this into 3 cubed. What does that mean? Guess what? You got a 2 right here. Everybody, what number is supposed to be there if you don't see anything? What number is supposed to be there? Oh yeah, that's a 1. There's always a 1 there if you don't see anything. Oh, what did we do? What did that rule say? 2 plus 1, you add them together, that's going to be 3. You got the same base, the 3. 3 cubed. 3 cubed. Now, let me just take you through some of these very, very hopefully understandable examples. And if it's not that understandable, don't worry. Write the rule down and recite the rule every time we do this. So let me go ahead and show you an example here. What I'm going to do is, let's suppose we had something like this. Let's say we have 6x squared multiplied by, and let's go ahead and say, someone give me a random number between 10 and 20. I said 10 and 20. 15 sounds good. So 15, someone give me a random number between 2 and 5. 3 sounds good. So 15x cubed. Okay, so let's go ahead and work this one out here. We got 6x squared times 15x to the 3rd power. All right, let's try this out here. So what did we say we should do? Look at the top. We should multiply those numbers. I'm going to admit Barons. So we're going to multiply the numbers. Just those regular old numbers, those coefficients, those numbers in the front, multiplying. Let's do that work real quick. We got 6 times 15. Why did I pick those 2 numbers? To torture you. So here we go. 15 times 6. Here we go. All right, so one more time. We got 5 times 6. That's going to be 30. And then we carry that 3. And then 1 times 6, that's going to give us 6. But we have to carry that 3 to give us that 9. So we're supposed to have 90. Real quick, before I continue, don't want anybody to stop us here. Everybody, can we agree that 15 times 6 is 90? Before I continue. Just doing a quick check, making sure we're breathing. Cool. All right, so yeah, 15 times 6 is going to be 90. So you multiply those numbers in the front. That's step 1. That right there is step 1. Step 2, what we're going to do now is we're going to go ahead. Let me use a different color here. Let me use that light blue. Step 2, we're going to add the exponents of the same variable. So everybody, we got x squared, x cubed. What we're going to write is x to the power of 2 plus 3. And that's going to end up being 90 x to the power of what? Yeah, to the power of 5. Exactly. To the power of 5. Right on, right there. So we had to do a quick comprehension check here. Got to do a quick check here. Yes or no? Do you understand, first of all, that there are different rules for adding and subtracting polynomials and multiplying polynomials? There are different rules. Yes or no? Do you acknowledge that? Okay, let me just look through some of these first comments. Yeah, definitely going to be going through the whole notes again. So here you go, David. Nice of you to join us. All right, cool. All right, so there's that. Now I'm going to go ahead and show you guys now, my second question before we continue. So first of all, we understand there's different rules. Second, do you understand that for adding and subtracting, once you know that they're like terms, again, I got the same variables with the same exponents on those variables, all you're doing is adding and subtracting that front number and keeping everything else the same. Yes or no? Are we feeling good about that for adding and subtracting? just go ahead, add those numbers in front. Once you know that they're like terms, add those numbers in the front and we're set. Or subtract them depending on what you're doing. Okay, great. My last question. So if you said no, don't worry, I'm paying attention. I got you. Because I'm going to making sure that I'm going to be continuing to re-emphasize those points. So I need you guys to be honest. If you're not understanding it, say so, because that's going to help me with my dialogue coming down the road here. Now, my last question before we continue is this. Do you understand that when you're multiplying polynomials, all you're going to do, multiply those regular numbers and then add the exponents on the same variables. So if you have an x times y, that's just x times y. But if you got x times x, that's x squared. Do you understand that? And again, be honest. Be honest. All right. So with that said, time to fool around, time to get fun. Let's go ahead and get started, man. I've been teaching for over 10 years, and I got a master's degree in math education, which is my specialty, but I also teach English and general science as well. At the end of the day, I want to make sure that you can stress less and not have to worry about having anxieties about the test, being able to actually not blank out and feel confident about what you're doing. And at the end of the day, are you able to study consistently and know that you are growing? That's really what matters to me the most at the end of the day. So that's why my program is here for you to help you succeed. It has everything you need: the classes, all the recordings, all the practice you'll need, and the ability to text me directly. So you have your coach with you, mentoring you every step of the way until you pass. I'm serious about your success. So go ahead and click the link in the description of this video or somewhere over here. That way you can watch how it works, see all the details, and sign up and start raising your score right away. If you have any questions, my phone number is 567-698-8867. Again, I'm Coach Anderson. Text me and ask me about the program, or click the link and watch how it works. Let's get this done. Let's raise your score and get you that job you deserve. Let's get to it. Here we go. So, no worries, Dwight. I got you, man. I got you. Let's go ahead and take a look at some of these examples here. So first of all, we're going to have a guided warm-up here. We're going to be multiplying monomials. Mono meaning one. So basically, one-term polynomials. That's all we're talking about. I'm going to be multiplying 1 times 1. One of them times one of them. One of them times one of them. One of them times one of them. So that's all we're doing. We're keeping it very simple, sweet, to the point here for this first example set. Then we're going to get a little more complicated. So let's go ahead and start off right here. 3x times 4x. And if you want to work ahead, go ahead and get this one done right here. But here we go. So everybody, when we're multiplying, what do we do with those regular old numbers? What do we do with the regular old numbers? What do we do? I'm not asking what the result's going to be. I'm asking what we're supposed to do. Give me a good phrase or sentence. Right, we're going to multiply them. We're going to multiply them. Now, everybody, are we supposed to check if these are like terms first? Are we supposed to? That's a nice little comprehension check question. Are we supposed to check when we're multiplying? Do we need to check if they're like terms? And this is where I'm teaching. So half of y'all said yes. Answer is no. When it comes to multiplying polynomials, doesn't matter if they're like terms or not. Doesn't matter. Does not matter. Because remember, you're just going to add the exponents anyway, right? When it comes to adding and subtracting, yeah, you need the same ones because you need to be talking about the same things. When you're multiplying, nah, doesn't matter. Here, you're just going to take that 3 and that 4, multiply them, and you're going to get 12. Now, what did we say we were going to do with the exponents here on these x's? What did we say we were going to do? Right, we're going to add those exponents. But my follow-up question, Mohammed, you probably know what I'm going to ask. Mohammed, raise your hand. Let me give you the mic. Mohammed, what do you think I'm about to ask right now? What do you think I'm about to ask right now? I want to know if you know. Can you read my mind? Mohammed, what am I going to ask?
You can ask what's the exponent for x for each one.
Mohammed,
I would say 1. They say
yep.
1.
Mohammed, this is exactly why I like having you in class, man. This is exactly why I like having you. Mohammed, do you have kids?
Yeah, I do.
Yeah, that's why. Yeah, automatic dad teaching mode. So boom. Yeah, so we have an exponent here. We have an exponent of 1 on each of them. And what we're going to do is we're going to go ahead and add those exponents. So x to the power of 1 times x to the power of 1. You're going to add those exponents, 1 plus 1, and it's going to equal 12x squared. That's what that'll be equal to. not 2x, x squared, x squared. Right on. So I'll give it a couple moments there. If you want to screenshot that, feel free. Let's go ahead and get into this next example now. Next example, let's check this one out. Before I even begin, is anybody here looking at this like, yo, there's a negative, homie. I'm not feeling this right now. I don't think we should be doing this. Anybody getting nervous just because of the negative? Okay, I see my people who've been in my program. I see y'all, okay. Good, good. Be honest though, if you are getting a little jittery about negatives, that's something that you want to acknowledge. The negatives will be there on the ASVAB, so don't just pretend that they won't appear. That's easy points you can get if you know the rules. Just because you don't know the rules now does not mean you cannot learn the rules later. Stop selling yourself short. Put in the time, put in the work, put in the effort. You'll get it done. So here we go, my party people. Hey, Edward, no worries. You're good. I'm glad to have you. So first and foremost, we're going to multiply these numbers together. Everybody, what's the negative times a negative? Who remembers? Negative times a negative is a what? Yeah, it's positive. If you didn't know that, you got to know that. All right. If you didn't know that, you got to know that. So I'm going to write this down briefly. This is the only time I'm going to write it. Here, a positive times a positive is a positive. A negative times a negative is a positive. But then if you have opposite signs, so a negative times a positive or a positive times a negative, you will have a negative. I just did a class on negative numbers last Monday. We just did this. So remember, if they're the same sign, they're having a good time. Same sign, good time. Same sign, good time. Opposite signs, bad time. Opposite signs, bad time. That's it. That's with multiplication, everybody. Multiplication and division, not addition and subtraction. I got to say that nice and clear. There are different rules for that too. But here we go. Next up, just follow the rules here. 7 times 3. Help me out, my party people. 7 times 3. Yeah, no, last week I kind of used a different representation. I think I categorized it as introverts and extroverts. We're not going to go back to that type of example. So we're just going to say good time and bad time. But yeah, 7 times 3 is going to be that 21. Next up, we're going to have over here m cubed multiplied by m. Can we multiply these? It's m cubed, but that one's just an m. Can we still multiply them? Can we still multiply them? There we go. I like testing you guys' confidence. I like testing your confidence. The answer is yes. Remember, when you're multiplying, you do not give a hoot about them being like terms. You're going to multiply the regular numbers together. You're going to multiply the signs together. You're going to multiply the same variables together. And that's it. You don't need to worry if they're like terms or not. That's only for adding and subtracting. Only for adding and subtracting. No worries on writing. Again, the more I repeat it, the more it's going to make sense. I got you. So here we go. So we're going to have m to what power? What are we supposed to do with those exponents? What are we supposed to do, everybody? Right. We're supposed to add the exponents of the same variables when we're multiplying variables. That's a 1 right there. So that's going to be 3 plus 1 as the exponent. And then lastly, we have n and n to the power 5. Remember, there's a 1 right there. There's a 1 right there. So we're going to have n to the power of 1 plus 5. Once we simplify all of this, let me go ahead and give myself less of a thickness here. We're going to have 21 m to the power 4, n to the power of 6. Yes or no? Did this example make sense to you? And if no, I need you to be specific. Was it the negative that tripped you up? Was it the variables? Was it the exponents? Did you forget that there's a 1 when there's no exponent there? What was it? So give me a yes if all of it made sense. Give me a no and the reason why not if it didn't make sense. So this is me teaching you how to point out where you're struggling at. If you can point out where you yourself are struggling at, then you can make progress sooner. You know, I don't want you guys to be here being like, okay, you have to rely on the teacher. I want to teach you how you can better rely on yourself. Variable, forget about the 1, forget about the 1, forgot about the 1. It happens. It happens. Right, if you know the rules, it won't be an issue. And that's why we're practicing those rules right now. So cool. Thank you guys for being honest. Yeah, forgetting about the 1. Cool, no worries. So then that's something you want to take a look at moving forward. Like, keep that in mind moving forward. I have to remember that if there's no exponent, it's a 1, not a 0. Cool. Let's go ahead and get to it here. Everybody, have you noticed how I've been doing this piece by piece? I'm not looking at this as negative 2x times 4x cubed. I'm looking at this as a negative times a positive, 4 times 2, and x times x cubed. When you know the rules, you can simplify the steps. Instead of one big step, you got 3 tiny steps. Here we go. Everybody, we have a negative multiplied by a positive. What's that going to be again? We got different types of people mixing together. Yeah, not going to be good. That's going to end up being a negative. Okay, sounds good. So a negative times a positive, that's going to end up being negative. Next up, I'm going to worry about multiplying the 2 and the 4. Help me out, everybody. That's going to be the hardest thing of the day. All right, that's going to be 8. 2 times 4, that's going to be 8. And then lastly, we're going to have ourselves x times x cubed, which would be x to the power of 0 plus 3, right? Yes, no. X to the power of 0 plus 3, right? I'm just waiting for somebody to say yes. No, it's a no. It's a no. Remember, the exponent that's there is a 1. Very common mistake, right? Very common mistake. People mistake that all the time. So we have to make sure we use the 1 right there. It's supposed to be a 1. And so our final answer is supposed to be negative 8x to the power of 4. Be honest, everybody, did this one here make more sense than the previous one? Did this one here make more sense than the previous question? Right on, right on. And if not, again, we want to be able to point it out. Why did it not make sense? But was I still missing out on that exponent being 1? Do I just have to really drill that in? What's going on, right? So let's understand that. Here we go. One more problem here. I got you, Shamaria. I got you. I got you. So you guys all paid a high amount of money for this class today. You paid all of $0.00, and you're still going to get $100 worth. Here we go. So we got 13xy squared multiplied by 4x squared y cubed. Okay, let's try this one out here. Michael, I got you, man. I got you. So let me zoom out just a little bit to be able to see both. I got you, Luan. I got you. So here we go. We're going to multiply these regular numbers together. 13 times 4. If we need to go ahead and use the space up here, that's more than fine. More than fine. 3 times 4, that's going to be 12. Carry the 1. 1 times 4 is 4. Carry that 1 is going to give us 5. So we have 52 right there. 52. And remember this, everybody, when we're learning in these classes, unless we're doing a day about calculating, we need to make sure that if you didn't quite catch on to the multiplication that I just did right up here, don't worry. Trust that 13 times 4 is 52. Even if you can't follow along all the way through right now, don't worry. You can do that later and confirm that. But trust that I'm not trying to lead you astray, okay? Trust that I'm not trying to. If I do make a mistake, trust me. I got Muhammad, I got David, I got Jose, I got plenty of people here that are going to call me out, especially Armani, especially Valerie. You guys are going to call me out if I'm wrong. And I appreciate that about you. So trust again. I am not going to lead you astray. So here we go. Up next, we got x and x squared. Everybody quickly, if you know it, don't say anything. If you know it, don't say anything. What exponent goes right there? So if you for sure know it and you've been answering all day, don't say anything. If you had trouble with it before, but now you know, what exponent belongs there? Appreciate you guys. I know you guys, some of you guys, you know it. I know it kills you not to say anything. You got David going over there, rattling in there like he's on the monkey bars. I see you, man. He's spitting bars at me. He's threatening me, it looks like. All right, David, here you go. That's a 1. So there's a 1 right there. And so that's going to be x to the power of 1 multiplied by x squared. So that's going to be x to the power of 1 plus 2. Up next, we have y squared and y cubed, and David has disappeared from the screen, so now I'm worried. So here we go. We have y squared and y cubed. Oh, there he is. So y squared and y cubed. So we're going to multiply these together, and that's going to be y to the power of what? Is it y to the power of 2 times 3 or 2 plus 3? What's it going to be? Right, that we're going to add those, exactly. Adding them, so 2 plus 3. So right on, right on. So our final answer is going to be 52. And what we're doing here is we have the x to the power of 1 plus 2. So that's going to be x cubed, or to the 3rd power. Then we have y to the power of 2 plus 3. So that's y to the power of 5. So I want to ask this specifically to Luanda. So Luanda, welcome in. So how are we feeling so far? Do we feel like we're starting to pick up on these rules? Because I know individually, all of them together look crazy, but are we able to pick apart the rule that you were struggling with? I'm not sure which one it was for you, but Luanda, were you able to improve between the first problem that we did over here and the last one over here? Were you able to improve? Perfect, right on, Luanda. See, this is what perseverance looks like. Keep giving it a shot. Keep asking those questions. So for everybody else, do you feel like you have confidently and you can articulate how you've improved from this first problem right over here through our second, through our third, and through our fourth, all the way through? Did you improve from start to finish? Good. This is what matters, everybody. This is exactly what matters. Now, we're not even close to finishing what the notes are for today. These are some of these essential fundamental facts that we need to get these big ideas down. This is how I teach again, I'm telling you. We have to make sure we have an undoubtable foundation. Because you know how the saying goes, you can't build a house on mud. You try to build a house on mud without preparing a solid foundation, you're building another house next week. So let's take the time to build the foundation so we can enjoy a house that we know can sleep us with roofs over our heads, nice and easy. Here we go. Fidelis, let me go ahead and answer this question here. So Fidelis, do we add the 1 on the x all situations, or is it only addition and subtraction? So Fidelis, in this situation, when you're multiplying variables, you add those exponents. The only reason we put the 1 was to say, hey, I don't see the exponent there, but remember, it's always going to be a 1 if you don't see it there. If you don't see it there. So that's all I wanted to say there, Fidelis. I got you. And you can look at the chat box there too. We have plenty of people that are always more than happy to help out in the chat box too. Thanks, Justin. Appreciate you. So let's understand now this part now. The distributive property. The distributive property. So everybody go ahead and type this into the chat box. I typically reserve this for some of these crazy classes, but I think it's worth it today. I'm going to make sure that I'm going to torture you guys because I can't be your mentor without being your tormentor first. Hashtag Ted Lasso if you've seen that show. So let's go ahead and write this into the chat box and click enter. I want everybody. We have 129 people here. I won't move forward until 100 people type this into the chat box. Make sure everything on the outside multiplies with everything from the inside. So I'm counting now. Go ahead. Type it in. Take your time here and click enter. Make sure everything on the outside multiplies with everything from the inside. Type that in, please. It's first 2 people, 3 people, and I will wait. Trust me. I got until 8 p.m. We're good. That's 6. That's 8. Ooh, now we're going. Got about 17 there. Okay. Keep it going, my party people. Make sure everything from the outside multiplies with everything from the inside. Or on the outside, on the inside. Either way you want to say it. But all we're saying is hey, look, make sure that everything from here mingles with everything from there. That's really what distribution is. Distribution is multiplication. Distribution is multiplication. So far, we're at 53 people. Thank you. Appreciate it. Keep it going. Make sure everything on the outside multiplies with everything on the inside. We've got 60 so far. Please don't double type. Got 61 there. And we really don't have to go to 75. I'm not expecting all 100 people because I know at least 12 of y'all confirmed are at work right now. So don't get fired. And please don't sue me if you get fired. I'm not responsible for that. Here's your disclaimer. All right. So here we go. Perfect. Thank you. That's 82 people. Thank you. All right. So if you're still typing it, please still finish typing out of respect. Please do. Please do. So here we go. Make sure everything on the outside multiplies with everything from the inside. I'm going to do the one with all positive numbers first, so I don't freak anybody out with negatives. So first and foremost, here we go. What this is going to look like is this, everybody. Here's the 5y squared. I got to make sure the 5y squared multiplies with the 4y squared. And I also got to make sure that the 5y squared multiplies with everything here, the 6y. That's what that means. That is all that means. Make sure that this thing, there's one term here and 2 terms here. Make sure this one term multiplies with the 2 terms. That is it. That is it. That is it. So with that, here we go. I'm going to mark this one in green so you see exactly what I'm doing. Everybody watch this. I have 5y squared. I'm going to go ahead and duplicate it over here. And I'm going to type right here 4y squared. And I'm going to add that over here. And I'm going to do the 6y in red. All right, so I want to show you this, everybody. Watch this. The 5y squared multiplies with the 4y squared, the green with the blue, right there. And then over here, the 5y needs to multiply with the 6y right here. And that's going to be the 5y squared, the same one, multiply with the 6y. Everybody, yes or no, are we seeing here that when I say distribute, we are talking multiplication? A quick check here, a quick check before we move on. When I say that we're distributing, I'm saying that we're multiplying. Just in more than one way, that's all that means. Distribution just means multiplying multiple times. So, cool. Let's go ahead and get to work now. Help me out, everybody. 5 times 4, what's that going to be? Perfect, 20. And then we have the y squared times the y squared. That's going to be y to the power of 2 plus 2. That's going to be y to the power of 2 plus 2. And so we'll talk about what that is in a moment. Next up, we have 5 multiplied by 6. What's that going to be? That's going to be 30. Great. And then we have y squared times y to the power of what? Pop quiz. Yeah, y to the power of 1. Yeah. So that's going to be y to the power of 2 plus 1. Bam. There you go. And now we're going to simplify here. 20y to the power of 4. And then we're going to have 30y to the power of 3. And there it is. With my big old head in the way. We're good there, though. So Marquette, so let's see what Marquette's question is here. So Marquette asks, hey, can't you also just do the parentheses first, then times it by 5 and still get the same answer? Not quite, because you still have to account for that variable, that y squared. So you have the right idea. You can just say, hey, multiply everything on the inside by 5 and multiply everything on the inside by y squared. That's exactly what I just did. That is verbatim, start to finish, exactly what I just did. If that's the question you were asking, then yeah. Hey, right on, Krishan. There we go. There we go. So I'm going to leave this one there so you can still see the example. And I'm going to have you guys now try this out, okay? I'm going to color code this. The 2x to the power of 6. You got to make sure it multiplies with the 9x squared. And you got to make sure it multiplies with the 8x. I'm going to give you guys a little bit of time here to try this out. So let me go ahead here, put my timer up. Where is my magical timer? Go ahead, pop up, please, and thank you. And then let's go ahead and not open up my math app. Where is my timer? There it is. And let me give you guys a minute, 20 seconds to try this one out. Go ahead, my party people, try this out. Type ready when you're ready. Don't give me the answer. Just type ready when you're ready. And if you get stuck, I promise, not promise. I just really hope that you saying you're stuck doesn't mean that you didn't try at all. I really do hope that you tried. Number 2, if you are truly stuck because you tried, please be ready to articulate why. Did you forget that, what was the rule for multiplying the variables? What do I do with the numbers? I forgot what to do with this. Like, be able to explain why, right? I want you to be able to explain why. That's where I can be my best to help you. So 40 seconds here. Do your best. Do your best. Even if you only get the purple. Even if you only get the first multiplication, that's fine. That's fine. I will be here enjoying myself in this hoodie. That's awesome. You should get to if you'd like to. All right, looking at our final 5, 4, 3, 2, and 1. That's time. So feel free to type in your answer if you'd like to. If you'd like to. No need to if you don't want to. Jalen, you sound like you're a little peanut butter and jealous. I don't know, man. So here we go. We have 2x to the power of 6, and then we're multiplying that by the parentheses 9x squared plus 8x. Okay, let's go ahead and try this out here, my party people. Here we go. That 2x to the power of 6, that's what you're multiplying everything on the inside by. All right, And then we're going to multiply first by the 9x squared. And then again, we are going to add because it's plus, plus. So positive times positive is still plus. And then we're going to have 2x squared again. Or excuse me, 2x to the power of 6, my bad. 2x to the power of 6 multiplied by that 8x. So just want you to realize again, however many terms there are here, that's how many times this multiplies. You see that there twice. There's 2 terms on the inside. You see 2 instances of that 2x to the power of 6. So now let's keep it going here. Salvatore, do we continue after we add the 18 and the 16? Let's find out. Let's find out here. Let's see, Salvatore. So here, let's go ahead and look over here for purple. 2 multiplied by 9, that's going to give me 18. X to the power of 6 times x to the power of 2. That's going to give me x to the power of 6 plus 2, which turns out to be 18x to the power of 8. Next up, I'm looking at the right side over here. I'm going to use green to represent that. I see that we have 2 times 8, which is 16. And then x squared multiplied by x, or excuse me, x to the power, I keep saying squared. X to the power of 6 multiplied by x, which is x to the power of 6 plus 1. And so that's going to give us 16x to the power of 7. So with that, now that we're looking at this, can we keep going? Are these like terms, everybody? Are these like terms? Can we add the 18x to the power of 8 and 16x to the power of 7? Can we add these? Can we add these? So I see a lot of y'all saying yes. I see some of y'all saying no as well. The answer here is no, we're done. They're not like terms. These are not like terms. You're done. So that's it. We finished. Here, we have finished. Right here. These are not like terms. They are not like terms. So there's no more simplifying. They are not like terms. No more simplifying. Again, they need to have the same variables, which we do have. We do have the same variables, but we do not have the same exponents. We do not have the same exponents. That's why we can't bring these together. That's why, everybody, although we do have the same variables, we do not have the same exponents. And so because of that, that's as far as we can go here. That's as far as we can go. Hey, Michael, no worries, man. Michael, shoot me a text. I think you're already texting my assistants earlier. Well, go ahead and shoot me a text. I'll go ahead and take care of you and talk to you more about this. I got you. So here, everybody, yes or no? Do we understand that we can't combine these? We can't go any further because they are not like terms. Oh, let me go ahead and make sure I don't miss these questions here. Right, exactly, Krishan. When there's no like terms, you just leave it. That's it. You just leave it right there. Exactly. If it's Teo, no. So, well, it depends on what the question is. They might have you break the parentheses down or factor, but typically you'll know what you're doing. You'll see the answers. You're good. Yeah. Yeah. It'll be a lot clearer when it comes to this. Let's see. Could you turn that into distribution? Well, we did. So Alex, remember, we just did distribution. We distributed the 2x to the power of 6 into both of these. Cool. All righty there. So David, what's up, boss? You have a question? I got you. I gave you the mic there. Let me know if that works out for you.
Mic check.
1, 2, 1, 2. Got him.
Hey, how you gonna steal my line like that, coach? I'm hurt.
That timing was immaculate, though. Everybody got that timing down, didn't I? I got that timing down.
Okay, look. Well, guess what?
Dude.
Yeah. Okay, look, I'm getting there. Relax.
All right, here we go. Go ahead, David. What's your question?
All right. Okay, no. I can't even think. But okay, coach, like as always, because at the you know what I'm saying, I'm multiplying. I know I'm the goat at this. I am. But let me know always. Let me know if I'm bugging. All right. So you saying like we can't combine these, right? And this is also I was curious about the last question too, because they're both x, right? They're both x, right? So I'm not crazy. So if they're both x, that means they can go together, right? Because we clearly just combined the x's up there.
Yes, so you're half right. You're half right because you do have the same variables, but we do not have the same exponents.
What you mean I'm half right? I'm the GOAT. Well, actually, you to go. Actually, no. I'm kidding. I'm playing. Okay.
So half right here. Half right. You have the same variables, but you don't have the same exponents. And so because of that, yeah, you need the same exponents to call them the same terms. So the example is like this. If we're saying like x to the power of 8 or even x squared versus x, these are two different terms. If you have x and x, you're saying maybe, pineapples and pineapples. But here you might be saying apples and pineapples. And so you can't combine them. You can't add them. If they have different exponents, they are technically different terms. Here's another example, David. Here's another example that I know is going to make sense. Here's an easy.
Okay.
Let's say we're talking about adding perimeter and area.
Ooh.
Does that make sense at all?
Ooh.
Could I add 2 inches and 12 square inches?
No, sir. You can't do that. You can't do that.
That makes no sense, right? And notice the only difference is you got inches and square inches. Here you got a distance, and here you have an area. And you can't combine the distance and an area like that. Sentiment. It's the same sentiment here. You cannot combine them because they are not even the same unit, is what we're saying here. They're not the same unit.
Okay, so
when we say they're not like terms, they're not like units. But you guys wouldn't understand units unless we're looking at like inches and feet and miles and meters. But technically, it's the same idea as having the same unit.
Yeah. Because I get like the inches and stuff like that. But the only thing, because with that, all I was looking at is like, okay, 18x, 16x, they both have x, they both have numbers above them. That means they can go together. That's kind of like my mind frame about it as I was solving the problem. I got the answers right so far because I'm the GOAT at this particular department. But yeah, I was kind of getting ahead of myself a little bit. Yeah, I can see.
Yeah, because that's what goats do, right? All right, let me mute you. So with that, let's go ahead and move on forward here. So with that, man, like you got me, my glasses changed out of nowhere. I don't know what happened, man, but whatever. So let's go ahead and try this last one out, my party people. So hopefully all of us, out here, we're gonna go ahead and have a good time. So we have 7x cubed multiplied by 8 minus 3x squared. So look, David, I know you can get this one right because of course you're the GOAT. So what we're going to do is we're going to have David go through this question with us after about 1.5 minutes. So I want you guys to try this one out by yourselves here. Just get as far as you can. I'll give you the 1:20. Try it out, get as far as you can. And then we're going to go ahead and work through this together. So just David, if you would like to, we're going to get ready to kind of go through this. And we're going to take a slightly more serious tone because we do want to make sure we keep good time for the class. But I want you to try this one out with me.
All right, y'all. Time for the GOAT to get into the building. Mic check. 1 2 1 2. How y'all doing? All right. Now it's time to get serious. Now, what we got here is 7x with the 3 on top, times 8 minus 3x with the 2 on top. So obviously, we can't really look at, the x or, the exponents on top. So really, we're just going to do 7 times 8, which is 56. You know what I'm saying? We just got to get those out the way. And then we just got to look at minus because we got to keep the signs.
Pause. 1 second, David. A couple people have questions here, and I do too. So we have the 7 times the 8, which is the 56. We got x cubed times nothing there. What do we do with the x cubed?
The x, I'm pretty sure because all signs have to go down. So I'm pretty sure we just have to keep the signs because we got to keep the signs.
Right, just leave it there. Exactly. That x cubed just stays there. X cubed.
Yeah.
It just follows along. It's like saying, yo, what's 2x times 3? Well, you're saying you got 2 x's times 3. Now you got 6 x's. So you're cool. Yep.
Right. All right.
And keep it going, boss.
All right. Now what we gotta do next is we gotta keep the sign. So it's gonna be a minus there. And what's next is we're gonna have to do, again, think of it just like regular numbers, y'all. 7 times 3 is gonna be 21. Yeah, 21. So, and then what we gotta do, because we have x's now. We have x's. We got 3 x with 3, and then we got an x with 2. So what we got to do, we got to add them up now. So that 3 and that 2 is gonna turn into what? A 5x. So we got 21x with the 5 on top, y'all. It's spicy like that. Hit that like a smooth criminal. Come on now.
All right, sounds good. So before we start experiencing a major occurrence of hubris, we're going to move on here. So appreciate you, David. Appreciate you, David. Don't forget that hubris is a sin. So here we go. We're going to go ahead and keep it up here. But no, great job, David. Absolutely amazing job. David, that was flawless. I only stopped you earlier. It was the only reason because I know some people may have had that question, but you did this up and down, mopped it up. Good stuff, man. Good stuff. He thinks loud. Well, hey, that's a good trait to have. I'm assuming that David has a really good internal monologue going. He probably thinks a lot of things through. It's a good trait to have. Good trait to have. So great job, David. I appreciate that, man. So yes or no, everybody, or on a scale of 1 to 10, everybody, how are we feeling so far about this? On a scale of 1 to 10, with 1 being, yo, I've been wasting my whole time being here. I haven't learned anything. That sucks. To 10 being, I've either really reinforced something that I've already known, or I've learned something new and I've cleared up some confusion on some of this math. And anywhere in between, again, you express how you're feeling. You express how you're feeling. Okay, I saw someone who had a question. So Alexandra, please go ahead. You have your hand raised. Sounds good. Alexandra, what's up? How can I help?
Yes, so I have been out of school for quite some time. I'm not just a student. What is the best way to learn multiplications? I'm starting from scratch.
Yeah, best way to learn from multiplication starting from scratch. I would definitely go starting off like for free stuff. I would definitely start off with YouTube and just say, hey, how to multiply or how to divide. Like just seriously type that into YouTube. And those videos are going to say like, okay, kindergarten, first, second, third, fourth, fifth grade. And that's fine. Don't worry about what grade level. It's going to be actually way more visual and it's going to be very, very entertaining. So do that. Start from scratch, start from there. Then from there, work your way up to working with decimals, working with fractions, working with negatives. But start with the fundamentals first and work your way up. Because at the end of the day, and I'm talking to everybody when I say this, you cannot escape the types of numbers on the ASVAB. You're going to be dealing with negatives. You're going to be dealing with decimals, fractions, percents, whole numbers, everything. So those will never go away. You might see geometry, you might not. You might see this, you might not see that. But you will always see all types of numbers. So Alexandra, that's my advice to you. Let me know if that makes sense. Okay. So with that, everybody, what we're going to do now is we're going to get into the multiplying binomials here. And after that, then we are good to start the timed drill set practice. So let's go ahead and take care of business here. And then let's move forward here. Simplify the following. We've got x minus 1 multiplied by x plus 3. So everybody, please, very briefly, one more time, type it into the chat box. Please do me that favor. What did we say? The distributive property, what did we say? Distributive property, what was it again? What was that phrase? What was that sentence that I had you write down? Please go ahead and type it in one more time. Dorian, appreciate you, boss. Make sure everything on the outside multiplies with everything on the inside. Dorian, I know that you got this, and that's pretty good to see. You have your notes ready, and you've been practicing with them. Eventually, you won't even need those notes. But please type that in one more time. I got you, Dwight. So everything from the outside multiplies with everything on the inside. Thank you. So here's what that looks like, everybody. Here is what that looks like. Right here, the x multiplies with that x. This x multiplies, let me switch colors here. So these x's multiply together. The x and the 3 multiply together. So look, this x multiplied with everything on the other side. Then we're going to take that minus 1 and we're going to multiply that with everything on the other side. Right there. And so that's all we're going to do. We're going to multiply everything from the one parentheses with everything from the other. That's what the distributive property is. It doesn't matter if it's one term on the outside or two terms in a parentheses, or even three terms in a parentheses, or 25,000 terms in a parentheses. It really does not matter. Really doesn't. You're just going to follow that one general rule. And if you know FOIL, so anybody coming in here who knows FOIL, look at this. First, outside, inside, last. Does that look any more familiar now? Does that look any more familiar now to anybody? Yep, that's exactly why it's called FOIL. It's a mnemonic device that's pretty much aimed at helping you remember the process of the distributive property. But the reason that I don't teach FOIL, I don't like teaching FOIL, is because it really deprives you of using it in more situations than just this. Because here, FOIL only works when it's 2 by 2. But again, FOIL does not work when you have something like this, like x plus y, then you have x squared plus 3xy plus 2y, something like that. It doesn't work when you have more than 2. It doesn't work. And so that's why, knowing the general rule, just say, hey, this has to go here, 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 and this has to go here, here, here. If that's all you worry about, then you're good. You know the general rule, and you're good. And you're good. That's the general rules. Like, again, make sure everything from one parentheses multiplies with everything from the other. Yes or no, everybody? Does that make sense? Does that make sense there? All you have to worry about is multiply everything from one parentheses with everything from the other. Drawing your little arrows, that's going to be the best way to do it. And you get faster at it and faster at it the more you do it. That's all you got to worry about. So let's get to work here. Let's get to work. Let's zoom on in over here. I'm going to have to move this out of the way. Okay, so let's try this out here, everybody. Let's color coordinate, or it's color coordinated. Let's go ahead and just go step by step, everybody. All we had to do was say, hey, yo, we got 2 over here and 2 over here. Mix them all together. The x goes with that one and that one. The -1 goes with this one and this one. You just have to make sure it multiplies with everything. Now, everybody help me out. X times x. Let's write that out right here. X times x. Everybody, what's x times x going to be? Help me out, my party people. Yeah, that's x squared. Exactly. That's going to be x squared because you have x to the power of 1 times x to the power of 1. So that's going to be right there, x squared. All right, let's keep it going here. Let's take that purple route now. X multiplied with the 3. Everybody, if I'm saying, yo, I have this x right over here, and I'm multiplying it by 3, what do I write? 3x. Exactly. I will just write 3x. All right. So we've taken care of everything with x. Pay attention here. So briefly, everybody put your pencils down. Put your pencils down. If you're even confused, slightly confused, or mega confused, definitely put your pencil down. I just want you to watch. Just watch, and then at the end, then write it down, okay? Because it's really important to understand this in layman's terms in plain old English. That way we can take those notes and then solidify it over time. It's not going to happen instantly if we try to take notes and listen at the same time. So here we go. What we needed to do, everybody, put your pencils down. What we needed to do is this. Multiply everything from here with everything here. So this x goes with both of them. X with x, x squared. X with the 3, that's the 3x. And I just dropped it down right there, just showing the next line. Now that we're done with mixing this x with everything over there, now the -1 gets to mingle with everything else now. So now I got the blue over here. Now, everybody, question. Do we need to worry about the sign? The minus on the 1, do we need to make sure we bring that with us? Yes or no? Do we bring that with us? I love the yeses. Yeah, we absolutely do. Absolutely do. So let's go ahead and mark that right there. It's going to be -1. It's going to be -1. So we're going to have ourselves -1 times x. Everybody, -1 times x is going to be what? All right, -1x. Everybody, what's another way to write -1x? Right, just minus x. It's like saying, yo, hey, minus one apple, minus an apple, right? It's the same thing. We're saying one. We're just saying one. And then lastly, in green, so we mixed again the x with the x, the x with the 3. Now the negative one with the x and the negative one with the 3. Again, you're just making sure that everybody parties together. That's all it is. It's one big party. Make sure everybody gets the party. So negative 1 times the 3. Everybody, a negative times a positive is going to be what? Negative times a positive is going to be that. Yeah, it's going to be that negative. So that's great right there. And then 1 times 3 is, that's right. 1 times 3 is 3 minus 3. And so with that, boom, what we're going to do here is we are going to have x squared plus 3x minus x minus 3. Are we done, everybody? Are we done? Are we done? No, we are not. What is it called that we have to do here? Starts with a C. What do we have to do? 7. No, we can do something here. We have to combine what? Combine blank blank. Combine blank blank. Combine like terms now. Now we have to combine like terms. But if you're asking me, you're saying, Coach, yo, homie, help me out here. What are you talking about like terms? Well, everybody help me define like terms again. Help me define like terms again, because I don't want to just be like, yeah, this is what it is. No, I want to make sure that we are all good. Everybody remember, like terms, what do they have? Like terms have the same what and the same what? Right, they have the same variable and they have the same exponent. So we have the same variable here. And we also have the same exponents. So everybody, which two terms here have the same variable and have the same exponent? Which one here has the same variable and the same exponent? Which two terms? Which two terms? Right, the 3x and the negative x, right here. These two have the same variables and the same exponents. So right here and right here. And so last question here before we actually do our work. What was the rule again? When we're adding and subtracting like terms, what stays the same and what do we actually combine? Help me out. And if anybody wants to raise their hand to answer that, sure, I'll give you the mic. So what stays the same? What do we actually add or subtract? Muhammad, go ahead, boss. Here you go.
So what stays the same is the x, because it's a variable, and what we combine, it's the numbers. I mean, whatever in front of the x.
Right. So if we have 3 x's over here and it says take away x, how many x's do we have left? Oh, give me the mic again. So how many x's do we have left, Muhammad?
So since 3x minus x, that's 2x.
Exactly. So 3x, take away x. Again, if you just say x, that's the same thing as saying 1x. So take away one of those x's, and we have 2x left. Everything else stays the same. X squared plus 2x minus 3. And we're done. Boom. Boom. And we are good there. So on a scale of 1 to 10, did that help you out at all in the sense of multiplying polynomials? We have 2 and 2, so 2 by 2. That one was a little different, right? Before we were doing just 1 by 2, so just distribute one term. Now we're distributing 2 terms. And again, it shouldn't matter. We should be able to distribute 3 terms, 4 terms, 5 terms, 6. It doesn't matter. We can do whatever we need to do here. We can do whatever we need to do. So I'm going to leave this example up here. I'm going to leave this example up right there. So I'm going to keep that there. We have another example right here. Try it out. Okay, I want you to try this out. Let me get that timer back up. I'm going to give you a little more time than 1:20. I'm going to give you about 1:40, so an extra 20 seconds here. Right there. Starting the timer now. So go ahead and try it out, everybody. Try it out. Yeah, we can definitely check our work by doing the inverse. So was that Armani? Yeah, Armani, you can definitely check your work there because the opposite of distribution is factoring. So if you've learned how to factor polynomials, you can try to factor x squared plus 2x minus 3, and it will revert right back to x minus 1 times x plus 3, if you know how to factor polynomials. But that's another session. We will be going over that pretty soon. Let me just double check the schedule real quick, because I know in the schedule, we will be going over percent basics pretty soon. Yeah, so we have proportions tomorrow. Then we have percent basics and percent word problems next week. Then we got law of exponents for the rest of the week there. So we don't have factoring, but we will be doing factoring next month then. We have a lot of new classes coming in next month that we will be doing. So get ready for that. All right, looking at our final 10 seconds again. If you have an answer, feel free to give it. But if you don't have an answer, if you struggled, just let me know what it was. Did you run out of time? Were you struggling to find the terms of like terms? Do you believe you messed up when you were distributing? Were you confused on the distribution? You know, it's so important to be able to point out why you're stuck. You know, you don't have to have the answers right away, but it's a good idea to be able to point out, hey, look, I know that this is supposed to be the process, but I'm not sure what this step means. That's the most important part, guys. So Arnold confused about the distribution. Brendan, if you could tell me why you were confused, like what were you trying to do? What were you trying to do? If it's like an overall confusion, saying, hey, I just don't know how to start, well, then maybe, okay, those notes, we got to take a look at those notes. What did you write down? What are we understanding? So here we go. Let's try this out. So Kadeja, I saw some uncertainty there. Kadeja, I expect more out of you because you, almost got it right. Almost got it right. Notice the v squared on the 5. Shouldn't be v squared. You're super close. That's the only thing. That's the only thing. So let's go and try this out, my party people. Here we go. Here we go. Oh yeah, Muhammad. I know what you're going to say, Muhammad. You're going to say, hey, the final number that's by itself, you multiply these. The middle number with the v, you add these. I know. We're not going to do the shortcut yet because I want to make sure people know how to do it the right way first. I know. So here we go. We're going to have v times v. Everybody, v times v, what's that going to be, everybody? V times v, v squared. Remember, guys, the idea is to multiply everything from one parentheses with everything from the other. So we've done the v with this v. Are we done using this v over here, everybody? Are we done? Are we done? Now, we're not done yet, right? We are not done yet. So now we need to multiply the v right there by this 1 over here. Everybody, what's v times 1 going to be? What is v times 1 going to be? Right, that's going to be v. That's going to be v. So v times 1, that's just going to be v. So I'm going to go ahead and bring this v squared down. This is going to be v squared. All right, up next, now we're going to take care of -6, the entirety here. Again, bring the sign with you. Bring that sign with you. And that's going to be -6 times v. Everybody, -6 times v, that's going to be, well, -6. So I can just put a minus there. -6 times v. And then lastly, lastly, what do you mean lastly? Are we done? Or do we need to do one more? Where are we at, everybody? Are we done? Do we need to do one more? What do we got? Yeah, we got to do it one more time. We had to do it one more time. So what we're going to do here is we're going to say -6 and that +1, we got to multiply them. That's the final piece of the party. Boom. Here we go. -6 times +1. That's going to give us what, everybody? -6. Yeah, -6, Kadeja. -6. Yep. -6. So with that said, my party people, there it is. That was the first step. You completed the distribution. So this right here, this first step was the distribution. Then you have to ask yourself, everybody, once you're done with the distribution, are there any terms that we can combine? Are there any terms that we can combine here? What's the answer to that question going to be, everybody? Yeah, we can combine like terms, but can you please point out kindly, what are those two terms going to be? What are those two terms going to be? Right, the v and the minus 6v. Those are like terms. Remember, everybody state it, please, in the chat box. These are like terms because they both have the same what and the same what. Let me highlight these for you. This and this right here are like terms. We can combine them because they have the same what and the same what. They have the same variable and the same exponent. So yes, we can absolutely combine these. We can absolutely combine these. So what this is going to turn into is we are going to combine these two right here. V minus 6v is like saying, hey, if I have, if I have one phone and I subtract 6 phones, I have negative 5 phones. And I probably shouldn't use phones, I probably should use money, but whatever. You get the idea here. The idea being you combine these and you say this is a positive 1v. So what's positive 1 minus 6? That's going to be negative 5v. You had one of these v's, you took away 6 of them. Now you owe or are negative 5 of them. And so with that said, everything else just comes down and stays the same. And there's our answer. Again, the final answer does not need to be simplified any further. We have v squared, we have v. Those are not like terms. And we're done. So who here got it correct for the first time? Who here got it right for the first time? Let's go. Let's go. That's what I'm talking about, man. That's what I'm talking about. That's what I'm talking. I mean, for the first time that we started doing these, the tougher ones. That's what's up, man. That's what's up. I love seeing that. I love seeing that. So with that said, we're going to go ahead here and get into that time practice because it's 7:37. So we are going to have enough time to probably get like 5 to 8 more problems in before time is up. And so remember, let's go ahead here and remind ourselves of these rules. Adding and subtracting, to be like terms, you need the same exponent with the variables, same exponents with the same variables. And what you do is you just add the numbers in front or subtract them or whatever, keeping those variables the same. That's it. Multiplying, dividing, very different story. Multiplying, dividing, what we do is we will multiply those front numbers. And with those exponents, we add the exponents of the same variables. So let's get to practice time, my party people. Here's what we're going to do. We're going to go ahead and give you 2 minutes per question. There's going to be 4 practice problems per round. So this is something I'm going to be doing more of moving forward. I want people from all ranges of skill levels to be able to feel comfortable practicing with me. So there's going to be 4 problems. I'm going to give you 2 minutes. Does that mean that if you don't get all 4 done in 2 minutes that you suck? No. It just means that, hey, look, try to pick one problem only. Just start with one. That's success to me. Pick one and try it out. Whether you get it right or wrong, no, that's not what matters to me right now. What matters is that you're trying so you can figure out where your experience led to, so you can point out those mistakes and understand how to either be more accurate or be quicker. That's what it's all about. It's either you're being, not as accurate as you need to be or not as quick as you need to be. Maybe sometimes both, but let's work on it one piece at a time. So 2 minutes. Let me go ahead and get that timer up. No pressure at all, everybody. Seriously, no pressure at all. My goal for you is to build comfortability and confidence. So 2 minutes, 15 seconds. Here we go. Starting now. You pick the ones that you want, and obviously my big old head's in the way. So let me go ahead and move myself out of the way. Cool. There you go. If you're struggling with the ASVAB, then it might be time to check out my ASVAB All-Access Program. It has all of my classes and the recordings, all the practice problems that you ever need, and you can text me whenever you need help. So there's much more to it, but feel free to click the link right here in this video or in the description that tells you a lot more about the program, and there's a video explaining how it all works. If you have any questions, I'm Coach Anderson. Find my contact info and reach out to me if you have any. Let's get to it and let's ace the ASVAB. Let's go ahead. Dwight, you tried one? Sounds good. Let's go. First one here. So what I'm going to do, everybody, is this is the point in class where having the recordings, if you're in the program, is really, really good because you can look back at these moments in case I go too fast. My goal now that we've gone over all of these examples, is to go a little faster so we can do a little bit more of the problems. So here we go. What we do here, we're going to do 2 times the p, 2p. Then 2 times -10 minus 20. Yes or no, did you get that first one correct? Give me a yer if you got it right. Let's try it out here. Let's go, let's go, let's go. All right, cool. You guys have no idea how grateful I am to have a full voice. Because some of you guys that weren't here didn't know that I was sick for quite a bit. It was a little over a month, but I'm feeling good, man. Let's go. So again, 2p minus 20, there it is. Now let's go ahead and go to the next one here. R minus 5 times R plus 4, excuse me there. Let's get to work here. Again, the rule is make sure that everything from one parentheses multiplies with everything from the other. Or as you guys specifically wrote down, make sure that everything on the outside multiplies with everything on the inside. So here, if we're looking at this, make sure everything on the outside of that parentheses multiplies with everything on the inside. I'll color coordinate it to make it seem a little easier. R times R, that's going to be R squared. Then R times 4 is 4R. Up next, we have -5 times R. Don't forget that negative. I'm telling you so many times, and you give me a yes, just laugh about it. It's okay, just laugh it off. Give me a yes if you purposefully avoided the negative because it disgusted you, and you just hope that the answer would still be right somehow. And be honest, like, it's okay. Be honest if that's what you did. If you ignored it because you were like, I don't like it, let's hope we're still good. That's not the right way to handle it, everybody. We want to be able to handle it the right way. And so just ask questions. Replace that tension with curiosity. Replace the tension with curiosity. So -5 multiplied by 4. A negative multiplied by a positive is going to give you a negative. 5 times 4 is going to give you 20. So there we are. Boom. And so we have combining like terms to do. Specifically, right over here, plus 4x minus, or excuse me, plus 4r and minus 5r. That's going to combine to give you -1r or negative r. So our final answer here is going to be r squared minus r minus 20. For number 2, if you got it correct, give me a yurt. Let's go. Let's go. So quick questions here. Okay, so Tony, raise your hand real quick. I'll give you that question there. Go ahead, Tony, raise your hand, raise your hand, raise your hand. There you go. What's up, Tony? What's your question?
Oh, I can hear you. So for my question is, for the 4 minus 5, right? So it would be 1, correct? Right? Correct?
-1.
Yeah, -1. But forget the positive because you take the 5, the higher number, right? You take because -5 is the highest number, right?
Oh yeah, you're talking about the rules for negatives. Yeah. So when you have the positive 4 minus 5, you just treat that as 5 minus 4, and you keep the sign of the bigger number, which was the -5.
Yes. Okay. Yes, sir. Got it.
Hey, right on, man. Good question. So if you again, if you're in the program, last week we did do a whole 2-hour class on negative numbers, and we went through everything beautifully. I actually put that class up on YouTube too on Saturday, so check that out. I got y'all. So with that, third one here. So notice, FOIL cannot save you here. FOIL cannot save you here. And so with that, we have to make sure we do this the right way. 5a times 8a squared. The 5 times the 8 is going to give you 40. Then you have a multiplied by a squared. Just remember that that is an a to the power of 1. So that's going to give you a to the power of 3 total. a1 times a2 is a3. 1 plus 2 is 3. Next up, we have ourselves 5a multiplied by 2ab. The 5 and the 2, just worry about the numbers first. Then worry about the letters. Notice how I'm breaking it down. Worry about the numbers first, then worry about the letters. So 5 times 2 is going to be 10. A times a is going to be a squared. The b is the only b there. There's nothing else, so just leave it as b. Nothing else to do. And then lastly, we're going to take care of this, the 5a multiplied by the -7b squared. So remember, everybody, just take it one step at a time. Make sure everything from one parentheses multiplies with everything from the other, which is exactly what we just did. 1, 2, 3. And now just make sure to focus on the negatives, the numbers, and the exponents on those variables. So we have a positive times a negative, which is going to give us minus 5 times 7, 35. A, there is no A here, so it's just going to be A. And then we have no B here, but we have a B squared, so just B squared. That's it. That is absolutely it. So, just like Armani, do your happy dance if you got it right. Let's go. I caught you at the corner of my eye. I caught you. But I love seeing that, though, Armani. I love seeing that energy because that shows that, again, you're invested in this process and you're doing a great job so far. Crush it. Let's go. Let's go right there. Boom. Boom. So I'm going to leave that up for just a few more moments while I zoom on over. If you want to take a screenshot so far of the first 3, feel free. We're going to try to sneak in one more round after this one, everybody. So here we go. This last one here, we got 4u minus 2v multiplied by u plus v. So you got to be careful here because you don't want to mix up your u's and v's. If you got bad handwriting, you probably mixed up your u's and v's a couple times here. So let's go ahead and not make those mistakes. Those variables were crazy. Did it on purpose. I like torturing. I like helping y'all learn. I like helping y'all learn. So 4u times u, that's going to give you 4u squared. Shamari, I'm joking. You know I'm joking. So here, next up, we got ourselves 4u times v. That's going to be 4 times u times v. Next up, we have ourselves over here, negative 2v times u. So it's going to be negative 2 times u times v. Now, this is a question that everybody asks. Is there a difference between negative 2uv and negative 2vu? Is there a difference, everybody? No. 1 times 2 is the same as 2 times 1. 3 times 2 is the same as 2 times 3. The order that you multiply by doesn't really matter. Doesn't matter. It's just proper practice to do it in alphabetical order, so it makes it more universal in terms of how people read it. Makes it easy. That's all it is. Just makes it easy. And so then, yeah, 2xy is the same as 2yx. Same deal. And then lastly, we'll have the negative 2u or negative 2v times v, so it's minus 2v squared. Now we do have terms that are alike that we can combine. We have them right here. The positive 4uv and the negative 2uv. And that's going to end up committing here. Bam, that's going to be 4 minus 2, which is 2. And so we'll just bring everything else down. 4u squared plus 2uv minus 2v squared. And there's the answer to the last one, my party people. Who's feeling good, man? Who's feeling good? Who's feeling good? And again, what I mean by feeling good, I don't mean, hey, were you able to knock out all 4? No. I'm saying, did you get 1 right? Did you understand the next one? You know, like, again, this is not a race. This is a marathon, and you have to keep improving and looking for ways to improve no matter where you're at. And that's why I always commend you guys for coming in, even with those situations where you're sitting here like, I have no idea what I'm doing at the beginning of class. And then by the time class is done, you guys are feeling pretty confident that you have the ideas down, the fundamentals down, because you can take that with you with the resources you have to keep growing. So that's why I love working with y'all, man. Here we go. Take a screenshot here. I'll give you a couple more moments. Take your screenshots. Take your screenshots. It's okay, Krishan. It's okay. 1 and 2 are great. Then we'll work on 3 and 4 later. We have another chance here. I'm going to give you the answers, and then we're going to wrap up class. Again, for those of you who want a shirt, stay. If you're interested in my full program, stay, and I'll explain exactly how it works and how to easily sign up. So here we go. Next, here are the 4 questions, and I'm going to give you all of the answers right after. Timer is starting now. Thanks for going ahead and taking the time to raise your score. I know it's not easy. I know it's tough. I know you got a lot to work through, so I do appreciate you. I'm Coach Anderson, and if you wouldn't mind, please go ahead and subscribe to our channel. That way you can get updated as we continue posting daily, so you can continue getting the help and advice you deserve. So, again, go ahead and subscribe to the channel. Let's keep rocking the ASVAB. So here are the answers, my party people. Here are the answers. Let's go. So for this first one, for 2n, or actually I'm going to give myself enough space to just write the answer for all four right away. So I'm going to put that right there. Okay, cool. So here are the answers. Number one, it's going to be 12n squared minus 22n. That's your first one. Your second one, what you're going to have is you're going to have 8u to the power of 4 plus 8u cubed v minus 4u squared v squared. That's your second one. Your third one, I'm going to go ahead and do this in one big swoop. Let me see if I can do this mentally. We are going to have 56r squared. Then we will have minus 62r minus 10. That's your third one. And then your last one, trying to do this mentally again. This one's going to be 20x squared. Then you're going to have yourself plus 45xy plus 25y squared. That should be it right there as well. And boom,